Bismillahirrahmanirrahim. Assalamu alaikum class. Today the topic of my presentation is count sort, radix sort and bucket sort. So basically our presentation you will be able to differentiate between these sortings. Okay, now what you get idea from counting sort. Basically counting sort, in counting sort we are going to count the numbers of elements in from this sequence. So from their repetitions or their presence we will sort them. How? I will let you know. So first of all, our array consists of three things. That is size of an array, which is A, and here are the indexes of an array, which are here 0, 1, 2, 3, and the largest value. We will use these three things to sort our array according to the counting sort. First of all, we will count the numbers according to their indexes. Like at 0, we have element 1. For knowing its count, we will create another array which will be count k, where k is the maximum we have. So basically, our count array is giving us or telling us about our range, that our elements consist of range from 0 to 12. So proceeding further, our count array will keep the check that how many elements or how many times our elements of array are being repeated or being given. Okay, proceeding further, as at index 1 we have element 5. For count 5 we will have plus 1 in our array. Okay, at element 6, which is at index 2, we have element 6. For count 6 we will add 1. Same like that we have other. So at index 5 we have element 1. For element 1 we have count 2 now. Same like that for 5. At index 6 we have element 5. For count 5 we will have 1 plus 1, which will be equal to 2. So now our 5 will have 2. Same like that for others of the elements we will have, another elements will have 0. Proceeding further, array A9. So now we have our count sort having the numbers of counts for our array index elements is. Now we want to arrange it in a way that it consists of indexes value, which will be n minus 1, which means that the sorted index will be n minus 1. Sorry. So now what we will do, now we will place 0 as it is down. Second one element is 1 for us. It says 2. So 0 plus 2 is equal to 2. We will place it here. 0 plus 2. Same like that we will do for others, that we will add the previous values in the next indexes and we will get that sorted indexes values. So proceeding further, as you are seeing that the values are being read and placed in the count sort. After having that edited values in the count sort, we will move further. Now, as we have the sorted indexes in our count array, now we want to arrange our array B, which is a new array which have made for our sorting. So our array B will consist of the sorted elements. At we will start from the last index, which is 8. At index 8, our element is 5. Count 5 have value 5. So we will do that 5 minus 1 is equal to 4. We will place uh, the 5 at index 4. See this 5 and 4. Same like that we will proceed further for the other elements. Like at 7 index we have element 12. Count 12 have value 9. 9 minus 1 8. 8 at 8 we will place 12. Same like that we will proceed further and place the other elements accordingly. The program that we will use is here. That function we will use to write our program. Proceeding further, discussing some drawbacks of count sort is that the major drawback of count sort is that the count sort consisting of negative numbers cannot be sorted, as it is very difficult for us to sort a count sort that has negative number in it. So for that, what we do, we replaces the negative values by the positive values by adding the most negative number that present in our array. So we basically add the most negative number present in our array to get the positive array. So after adding the most negative number present in our array, we get the positive array. for all positive values for all the elements present in an array, we will sort that positive array, and after that we will minus the value that have added it, and it will give us the original sorted array. Proceeding further, it is the algorithm of our sorting array. As I have mentioned earlier that there we are using the maximum value for our count loop. Count loop consists ends at k. So big of n for us will be n plus k, which means if we take k as constant, then big O will be O of n. But if the value of k is greater than n, then it will make our unstable sorting, as we have to work a lot for that. For example, take an example of an array having 100 elements and its maximum value is 20,000. For that, we will have to make a loop from 0 to 20,000, which is much bigger, way bigger than our total numbers. So it is the waste of time. So it is not stable way to sort 100 elements by using 20,000 maximum values, so 2000 20,000 count. For such situations, we use Radix and bucket sortings. So proceeding further, what is Radix? In Radix, what we do, for example, it is an array. What we will do that we will take the maximum number value, which is 320. We will change our array into according to the digits present in the maximum value, that we have 3 digits in the maximum value, so we will add zeros in the start of every element in our array to get up to 3 digits. So after getting 3 digits for every element, what we will do, we will move further and will arrange every element according to the least significant bit, which is our last row. What we will do now, we will arrange every element according to its LSB. So the number with 0 at the end will be placed at the first according to its position, and the numbers which having 1 at the end will be placed after the zeros values. So proceeding further, at pass 2, what we will do, we will arrange the numbers according to their middle numbers, middle, middle digits. The values with zeros will be placed at the starting, and the values which having the 1 or 2 at the middle will be placed at the other positions, as you can see here. And at pass 3, we will arrange the numbers according to their MSP, most significant bits. Here, at this step, the numbers with zeros are placed at the start, and the numbers with 1 at the second, and 2 and 3 at the end. And in this way, our array is sorted, and we will get our sorted array. Whereas in bucket sort, what we'll do, we will have a bucket range from 0 to 9. We will place every number in bucket sort according to their MSVs, most significant bits. We will bucket them according to their MSPs. Like zeros, the numbers which are having zeros at the MSP are placed in the 0 bucket, and the numbers which are having 1 at the start will be placed at the 1 bucket. 2 will be placed at the second bucket, as this. Here you can see that every number is placed according to their MSPs. Now, what we will do further, we will use insertion sort to proceed further, to sort them according to their values. So, insertion sort is used to sort every number according to their place. Here is a mistake, sorry, 032 and 091 at the end. So it is the correct way to sort an array using bucket sort. It will be our sorted array as follow. Here is our sorted array. Now discussing the algorithm of sorted array, as from our previous example we can see that it is run from 0 to n minus 1, which means it is running from 0 to n, which big omega is n. As we are using insertion sort, big O of n is equal to n square, and our list is okay. So big O of n is the time complexity for the bucket sort. Thank you. Hope so that I am able to answer your questions.